So, hello, my name is Tiago, and I work as iOS and tvOS developer. And today I'm going to present how it is possible to write framework-independent applications using Swift. We'll start with the motivation, why you write applications using this kind of technique. Then we'll see a structure of an application, how it has to be in order to be independent of the framework. After that, we'll go through a practical example of a sample application written this way. And then we end by seeing the benefits and costs associated with this kind of approach. So let's start with the motivation. One could say that the main reason to write applications this way is to achieve portability. I write my application once, and then I can run it everywhere. However, this is not the main objective of this approach. Nevertheless, we did it. Like we'll see in the example, I wrote an application that runs on iOS, macOS, and Linux, and uses all the same business logic. The main motivation with this approach is testability. We want to create apps so that they are easy to test. And you ask why? Mainly because of all the benefits we get from tests. By using test-driven development, we can easily get reusable components. We arrived at cleaner architectures supported by our tested features, but mainly because we get maintainable applications, where the tests act not only as a documentation of our app, but also as a safety net that guarantees that our app is always working. And the documentation from the tests is guaranteed to be always up to date. So that was the motivation. Now we look at how a framework-independent application looks like. The main concept is very simple. We only have to divide what is dependent on the framework from what is independent. That's it. We define a line from what our application is and does from how it does it. In one part, we have all the components that are dependent on the framework. These are our views, the sensors, the database, etc. And these components are usually accessible via the framework API. They are replaceable, and they are not essential to our app. When I say essential, what I mean is that despite of how we implement our application via an iOS or Android application, the functionality remains the same, despite of all the things that vary. In this case, the platform. Then, on the other side, we have the framework-independent part. These are our use cases. It is the heart of our application. This is more known as our domain or our business logic. And this is the essential part of our application that provides the value to our users. But then comes the question, how these two parts communicate together? They should obviously communicate. We need to draw something on screen, and we need to respond to user events. But in order for them to communicate, we need to communicate through abstractions using interfaces. And these interfaces should be written in terms of our domain. In Swift, we define interfaces as protocols. And this kind of approach got named in the community as protocol-oriented programming. In simple terms, it means that our objects talk in terms of abstractions of our domain instead of talking with concrete objects. So that was the structure of a typical application. Now I will go through a practical example. This example is a simple login application where you insert a username and a password, and if it is correct, it shows the main screen. The main screen is very simple and shows the meaning of life. How is the application structured? On one side, we have our view. In iOS, it can be defined with Xib, a storyboard, or by code. In this example, it's defined with a storyboard. Then to control it, we have the login view controller. That in iOS, it extends UI view controller. So this is the part dependent on our framework. For iOS, it is dependent on UIKit. On the other side, we have two collaborators, a presenter and a service. And these objects contain our business logic. The presenter is responsible to manage what happens in different use cases. For example, if the username is empty or if the credentials are invalid. The service has the responsibility of checking if some credentials are valid or not. And it can be a local or a remote service. This is the part that is dependent on our framework and is shared through all the sample applications. This part is easy to test, it is easy to port, and most importantly, it is easy to maintain. If we decide to use another database or another kind of service, or if Apple changes the API of the framework, we should not need to change this part. Another important aspect is that collaborators are injected into our framework independent parts, so that it is easy to test them and that we can choose their behavior by injecting different types of components and not by changing the collaborators. Well, what was the result we obtained with this approach? We did an iOS, a macOS, a Swift command line application, and an Inter app-to-app iOS application. And these four applications share the same logic, and this logic is unit tested. So let's take a look at these applications. I will start by showing the behavior of the applications, and then we'll look at the code. So starting with the iOS application. You can see some text fields, a password, and a login button. If I insert a username and a password, it validates it through our backend and shows us the main screen with the number 42. Then we can see the Mac application. The same behavior. We have our text fields where we insert a username and a password. And after that we do login, we see the main screen. Then the Swift command line application. I go in here and I build the application. And then I run it. We see that we need to insert a username and a password. I insert them, it loads, and then if the credentials are valid, it shows the number 42. If the password was wrong, it will say that the credentials were not valid. Then to end, we see the Inter-app iOS. This is an external iOS application that wants to use the advanced login system that we created. So this app communicates through URL schemes and calls our application. If I press login, it opens our application and it returns the result back. In this case, that the credentials were valid. Now, let's take a look at the code. We start with the tests. In here, we can see the tests for our login presenter. And these tests verify the behavior of our application. As we can see, it shows what should happen when the username is empty, if the credentials are not valid, etc. It shows all of our cases. Let's take a look at one, for example, this one. We see that from the assertion that these tests validate if that the view should show that the credentials are valid if we try to do login with some valid credentials. We start developing the app using defining these tests using TDD, and these are fast tests to run. I can run them. Since they are fast, since they don't depend on the network, on the file system. I will run again. So we can see in here the time. I don't know why I'm not seeing the logs. I'll try to run again. Okay, we can see they run under 100 milliseconds, so they are very fast. This approach has another advantage, is that since with the unit test we cover all our edge cases, when we write our UI tests, our end-to-end tests, they can be very simple. These are the UI tests for the iOS application. It only inserts a username and a password, tries to do login, and then waits for the label to appear on screen. I can run them. We can see that it inserts a username and a password. And after it is login, and our test passed. These tests, however, are 3 orders of magnitude slower than our unit tests. So we want to keep these as few as possible. A best practice is to test all the behavior of your app with unit tests, and then only test the happy case with one end-to-end test. We also define a UI test for the Mac application. This is very simple. In here, I insert the username and the password again, and I click instead of pressing, and then I wait for the label. I have to select here my Mac, and I run the UI test for the Mac application. Some username, some password. Okay, the test passed. So I even defined a UI test for the inter app to app. In this case, it taps the login button and waits for the result of the other application. Okay, I have to change in here. If I launch it, we can see that it launches our inter app to app login, clicks the login button, or maybe not. Okay, no. Let's try to launch it again. No, it cannot find the label. I'll try to run again the iOS app. Okay. And now the Inter app. Okay, now it seems that it doesn't work right now. If I try manually, yes, it returns, but through the test, it seems that is not is looking for an empty string. Strange. Let's see if we find out through the logs. No, it seems that right now it's not working. I will try to reopen Xcode, see if it helps. So if I try to launch it again, no, I don't know. I don't know why it's not working. Maybe with a clean emulator. Don't know, strange. Because if I do it manually, it works. Usually it's because an app that calls another app needs the permissions. Like we saw this one and this one. Manually it works through the UI test. Seems that is not able to read the label. Okay. Okay, now it passed. Seems that was a problem of the emulator. Okay. The advantage of using this methodology is also that we can run this test continuously on our integration server and verify that our app is always working, or if it breaks, to know exactly when it breaks. Now, if we look at the project, we see in here on the login folder, everything that is common throughout all these 4 apps. We see the concept of credentials as a structure that has a username and a password. We see the login presenter, our object that is responsible to do the login. Our login view, as someone who has some credentials, knows how to show these different kinds of states. The concept of token for the authentication. The login service has someone who knows to validate the credentials and notifies his delegate. Being the delegate, someone who responds to the credentials are valid or not valid. And the concept of a remote login service, as someone who extends login service and uses a remote service to validate the credentials. So this part is common throughout all the 4 apps. In here, on the Apple OS folder, we see everything that is common on the Darwin platform, in this case iOS and macOS. We see the Alamo Fire login service, a concrete a concrete class of remote login service. And in here, we use the Alamofire library. If we want to define another one, we only have to create another object that implemented this protocol. We see the login service factory that is used to inject this service on our iOS and macOS application, and the token extension to the token that uses the Swifty JSON library to parse the token from a JSON. On the cross-platform, we see the command line Swift application that has the package.swift to expose it to the Swift package manager. Our main.swift that reads the arguments from the command line creates a login controller and does login. The login controller that accepts some username and password, and when you do login, it does it using our login presenter object. And the implementation of login view from the login controller. In this case, as we saw, it only prints on the command line and displays the main controller when the credentials are valid. If we are using another GUI, we could use in here the methods to control the GUI. We see a dummy service. This one is not a remote service, but is a local service. We'll see that on iOS and macOS they use Alamofire. It's a remote service. In here is a local. The station of token that in here we ignore, and then our main controller that displays the number 42. So this is the command line application. We can look at the iOS application. Has a login view controller. As we can see, it's very simple. It mainly has outlets to access our view properties, and the response to actions from our UI. In view did load, we create our presenter and inject it the service created with our factory. That in this case, the concrete class is from Alamofire. In here, we see everything that responds to the login view, what to do in the different cases. As we see, it's very easy to get one-line, two-line methods that are very easy to understand and mainly drive the framework APIs. For here, we see that the username flashes red when the username is empty. Very easy to understand. And in here, like I said, the UI is defined with a storyboard, a classic iOS application. We can see the macOS application, very similar, but instead of using UI kit, in here we use Cocoa and the NS text fields instead of UI text fields, but is fairly similar to the other one. When someone clicks the login, we just delegate to our presenter to do the login. In here we see all the callbacks. In here, instead of flashing, we just set the background color to red. And we use a progress indicator instead of activity indicator. But they are very, very similar. Also, the UI in here is defined via storyboard. Okay. So now let's look at the benefits and costs of using this kind of approach. Like we saw before, it's very easy to test since we don't have any dependency on the framework interfaces or networking or file systems. The application is easier to understand and it's easier to maintain since we have everything documented and tested. We also have an abstraction from the framework where we define our use cases and the tests not regarding the APIs. And this usually leads to a better architecture and the application that is easier to port. Of course, we have some costs. First, it is needed a mindset change from the persons that are developing the application. Because sometimes, for a person that learns the framework, it seems just simpler to do everything on the view controller. People working with this kind of approach need to have training on the methodology, which means that if a person is starting on a new project, he has to learn two things: the framework, in this case iOS or UIKit, and this approach. And it's a cost to add. There is also a cost of interaction, not in terms of performance, but in terms of objects. Since we naturally are going to have more objects with this approach, and sometimes programming towards abstractions can be confusing to know where the concrete implementation is, or which kind of libraries or dependencies are we using. All the sample code that you saw is available at my GitHub. I will add some time if you want to check that out. And here you can find some reference I use for the presentation. In here, the concept is explained in more detail and in different ways. In some ways, it's platform agnostic or language agnostic. In some cases, it's explained with Android. On this link, you find my slides of the talk. And that's all. Thank you very much for your time. Now let's check if there are some questions. Seems that there are no questions. Maybe the mic is still off. Okay, where can I find the slides and the example code? Okay, I will just post directly the links in here. Slides can be found here. Let's see if this works. Yeah. And the sample code you can find at my GitHub. I will send the direct link. Okay. Yeah. Okay. You can also find the README in there and set up the project. It has all the requirements and instructions to install it and run it. Okay. Welcome. Other questions? Okay, there is one question. How long does it take to port an app? Okay, so it's really straightforward. It's really straightforward using this kind of technique, because like we saw, I developed all the login part using TDD in a way that was independent of if the application was running on iOS or Mac, anything. It was pure Swift. Only some parts maybe depend on Foundation, but with Swift 3.0, it will not be a problem. After doing that, I developed the iOS application, and to port it to Mac, it took like 1 hour, not more than 1 hour. And I never had done a macOS application before. It's really a matter of calling our delegate your behavior from the events of the user, in this case IB actions, and hooking the behavior through the UI. It's really a matter of that. Then to port it to be Swift, to run on Ubuntu or Linux, it was only a matter of doing the same thing, downloading the Swift toolchain and hooking up implement only the other parts. So it took also like 1 hour. Another question, how do you deal with changes in protocol? Okay, so if I understood correctly, how do I deal with changes in for example the protocol, for example this login view, and this is a very interesting question. I will share the screen for that. Changes that may okay, understood. Changes that may affect one platform but not another. Yeah, but like I said, that is the main reason why one should develop apps like this. Because like this, we are not hooked to the changes on one platform. For example, if Apple, I will screen share again. If, for example, Apple decided that right now you don't access the NS text field is deprecated, and you cannot use NS text field, but you should use the new one that is also deported UIKit to the Mac, and you should use UIKit, UI text field. You only have to replace the parts on the Mac application. All your business logic and the iOS and the Swift application and the other one remain the same. You only have to do very local changes. If I understood correctly. Okay, exactly. That was the other thing that I understood is that what do you do when the business logic has to change? And we can test it. Very easy. You only, if for example now I will define that my login view should not show that the credentials, show that the remote server was unavailable. Unavailable. And we try to run this, for example, the iOS application. We try to run our tests. And it will, the compiler will enforce us. And this is what is nice of working with a compiled language like Swift. The compiler will tell you exactly what we should change. For example, in here it says that right now my view controller does not conform to login view, and we should add the method that we just defined it in there. And for example, I will want to say that right now, when my remote server is not available, I will say to my user, check your internet connection. And I try to run it. Okay, now also the interapp does not. I will add to this one, I will add empty implementation. All right, we can hook. We can say that we return to can return on this is the interapp part. So we will return the message your server was not unavailable. So the ones calling our app receive this message. We can see that now the tests. What is nice is that we get feedback from the users, from the compiler, saying what we are doing, what we need to implement. And right now, I think that our app compiles. Yeah, our app compiles, but doesn't have the behavior. To add a new behavior, I will start adding a new unit test that will say, for example, test when server is not available, etc. And then I will write my test in here and add this behavior to my presenter that will manage for all the apps and so on. Okay. I don't know if that was clear enough, but the feedback is that we usually start with, to develop the features, we usually start with the end-to-end test. But in cases like this, where we want to add a new behavior, a small behavior, like this one, the remote server, is a perfect example, is that we start with a test that we want to assert, and then we go to make all the changes that the compiler enforces on us. We don't have to remember in all the apps, every point that we have to add new things and new changes. Okay. I don't know if that was clear enough. Okay, thank you. If you want, the open source project is the project is open source. You can add, you can try to add this to fork the project and try to add. Okay, what if I need to add a new thing to the protocol, but it is used only for one platform? Okay, so you have two options right there. Is that you can try to you could try to add nevertheless like we did before, and on the other platforms you give an empty implementation that just prints to the console, for example, does nothing. Or you can use the optional parts of Objective-C. If you link the protocol to Objective-C, you can define some methods as optional, and you don't have to implement them. Doing that, you lose the compiler that enforces you to implement that. Is that the two strategies? Okay. Thank you. Okay. Let's see if anyone has other questions. Okay. Seems that is everything. Okay, it's everything. So thank you for your time. Hope you enjoyed it. See you soon. Bye.